Alright, this screencast will be about something called logical. So remember when I type in x equals 1, 2 and say v equals t with quotation and I type in whose, notice that x is a double and v is a car. Now if I type in u equals 1 equals 1, notice that this part here is in parentheses and there is a double equal sign. Then there is a single equal sign. So let's break this down. If I just type this in, what MATLAB is going to do is it's going to say, does 1 equal 1? And the answer is yes, it does. Now, does 2 equal 0? No, it doesn't. Does 4 equal 5? It doesn't. Does 4 equal 4? It does. Now you can do interesting things. Cosine of pi, does that equal 1? Cosine of pi, oh my bad. Cosine of 0, does that equal 1? It does, because cosine of 0 is 1. But if I save this test into a variable, let's say cosine of 0 equals 1, you would think that u is equal to 1, but if you type in whose, u is actually a logical, which means it can only be a 0 or 1. Something, when you do a test, can only be true or false. Now there are other kinds of true and false. You have, is 5 greater than 5? No, it's not. Is 5 greater than 9? No, it's not. Is 5 greater than -1? It is. Is 6 less than 10? It is. Is 5 less than 2? It's not. Is 4 greater than or equal to 2? It is. Is 4 greater than or equal to 4? It is. Now is 4 greater than 4? It's not. Now I'm going very, very fast here, but the whole point of this being on YouTube is so that you can pause and rewind and understand what exactly is happening. And then obviously you have 3 is less than 5, which it is. 3 is less than 2, it's not. 3 is less than or equal to 2, less than or equal to 3, less than or equal to 4, so on and so forth. And then of course you have not equal to. Is 1 equal to 1? It is. Is 1 not equal to 1? It's not. So there's like some negation there. Is 5 equal to 5? It is. Is 5 not equal to 5? It's not. Now is 1 equal to 2? It's not. But is 1 not equal to 2? It is, right? So it's kind of a weird true false statement going here. Now you can do things, the reason why you have this is say you have x equals 5 and y equals 6, and I want to know if x is equal to y. It's not. X is not equal to y. Right? Now if I say x equals 5, y equals 5, and I say is x equal to y, then it says yes it is, because x is 5 and y is 5. If I say if x is, say, 8, and I say is x greater than y, it is, because x is 8 and y is 5, and 8 is greater than 5, right? So I can do these tests here and check and see if something is true or not, which helps me out a lot. I can actually make a vector, say 1 to 10, and I can say is x greater than 3.4, and it'll actually say that the first 3 are not greater than 3.4, but the last ones are greater than 3.4, which helps me out. What if I say x equals rand 1 comma 10 times, let's say this is going to be a number between 0 and 1, so I'm going to subtract 2, and I'm going to multiply this whole thing by 10. So I'm going to get, didn't like that, let's do -1. Didn't like that either. Okay, what's rand 1 comma 10? Let's slow down here. Numbers between 0 and 1. So if I subtract, let's subtract 0.5. My bad. Okay, so now I've got some positive numbers. I've got some negative numbers. I've got some positive numbers. Let's say I want to know all of the numbers that are greater than 0. Boom. Now it'll tell me all of the numbers greater than 0. Now this is what's even freaking cooler. So here's x. Now let's say if I say L is give me all of the locations that x is greater than 0, right? And then I say x of L. Boom. It'll give me all of the positive numbers. Rewind that. Try that again because it's awesome. Let's say I have x equals, I don't know, exp of 1 to 10, right? And, oh man, that's huge. Let's do is 2 raised to the 1 to third power, okay? Oh yeah, you need a dot hat here, remember? Okay, so we got 2, 4, 8. And I want x where x is less than 5. Boom. It'll give me all of the numbers that are less than 5. It's pretty powerful stuff when you do that. If you have x equals 1 to 10, and you have y equals 10, negative 1 to 1, and I want to know where is, x is equal to y. And it's probably going to say nowhere. It's not equal to there at all. But say x equals 1, 2, 3, and y equals, say, 3, 2, 1, and now I say z equals find where x is equal to y. Now the middle term is the same because x and y both have 2's in it. Okay, so there's a lot of things that you can do with logical tests. I urge you to watch this again to see all of the different things that you can do. Good luck.